Hello friends, in today's video lecture of machine drawing, I would like to deal with hexagonal nut bolt and square nut bolt, where these are used in our regular practice. You could see in your day-to-day life. Okay, now we are dealing with machine drawing, where today we'll try to discuss hexagonal nut, okay, and square nut. Similarly, hexagonal bolt and square bolt. Fine. Now I'll try to draw the 3D model of a hexagonal nut and square nut so that you'll understand the basic parameters that we consider when you take a hexagonal nut. Okay, let us draw a 3D model of a hexagonal nut. The nut arrangement is something like this. Okay, now which is having a circular hole from top to bottom, where we try to fix it in general when you look at the application point. And there is a circle or a circumference bounding all the edges. Okay, means these corners, have a look, these corners are having a fillet or bottom depth. Those are not exactly parallel to the bottom base of hexagon. They will maintain some inclination. These corners, 1, 2, 3, 4, 5, 6 corners. Okay. Now if this is the case, from here to the extreme end point, extreme two end points, we will consider as this, this is equal to D. What is D? D is diameter of hole. Okay, D is what? Hole diameter. Fine. So, and the radius I am talking about is something like this. Here you find the radiuses. These are the radiuses you find. Okay, now this radius, again it is having some standard formula which is equal to R, that is equal to 1.5 D. Again D is equal to whatever given in the question. Now for you, they'll directly give you the value of D. They'll ask you like, draw the front and top view of a hexagonal nut, or draw the representation of a hexagonal nut by taking D is equal to 20 mm or else 25 mm or any other value. Accordingly, what you try to do is, you need to remember all the standard formulas. Accordingly, calculate W is equal to 2D. Calculate W, calculate T, R, and start drawing your sketches. Okay. When you view from the front, you could see a true shape, that is 1, and two reducer shapes, maybe 2 and 3. Okay, when you view from the front, I can see 3 faces, out of which middle one is a true shape, other 2 are reducer shapes. And you could see all the 3 arcs. One arc is 1.5D, okay, and a hole, but which is invisible. Hole is not visible actually, because it will, a material will be there between the observer and the centrally drilled hole, which is having a threading again. How to represent threading, that all we'll see today in this session. Okay, now I'll try to start the representation, drawing representation of nut, hexagonal nut. Have a look. Now whatever the sketch may be, try to draw vertical and horizontal axis lines first. For example, I'll try to draw a vertical line where I'll start my view. When I view this particular component from the front, I could see only a portion of true shape. When I view from the top, I could see a true shape of a hexagon. Complete hexagon is visible from the top. So I'll start with the top view. This view. Okay. So I'll consider one more axis. I'll consider this as the center point. Then I'll take W value. W is equal to 2D. Okay. U is equal to 2D. Let us imagine D is equal to 20 mm. R is equal to 1.5D. That is equal to 1.5 into 20, and is equal to D, that is equal to 20. Now these are the specifications need to be followed to draw the front and top view of a hexagonal nut. Now I'll consider W, split it into 2 halves, which is 40 mm from here to this point. So 20 on both sides of the vertical. Okay. Now how to draw a hexagon in this portion? Now you can consider half of the distance, which is 20. With the help of compass, take this as center, whole thing as radius, draw one circle. Okay, draw one circle with 2H pencil. Don't draw with HB. Draw one circle with 2H. Now considering D as the radius, make markings from here. This as center, make a mark of D. This as center, make a mark of D. Again from here, D on either side. Take this as center. Let us name it as A, B. Okay, take A as center. On both sides of the horizontal, draw two curves, B as center both sides, D as the radius. Okay, join them all with the help of HB pencil. Okay, join them all. 1, 2, this is third line, 3. Okay, so AB, end to end point distance, and remaining things you could see. Fine. Now this is about a hexagon. Try to project them all above. Project this line 1 to draw the front view. 2, 3, 4. Let us make it straight. Okay, up to some infinite distance. After this, take any horizontal somewhere away from the top view. Somewhere away, take one horizontal. Now try to place the front view. When I view from the front, I could see only the thickness. What is the thickness here? That is again equal to D, which is equal to 20. From here, make a mark of 20. Close the box. Okay, so here in this box you are going to get the front view. This is about the top view. Okay, now what you need to do, calculate R value. R is equal to 1.5D. Accordingly calculate R value. Whatever the value you will get from this intersection, top horizontal of your front view, from here make a mark of R on the axis, cut the axis line. Now in a vice versa way, this as center, the whole thing as radius, draw a curve this way. Okay, this as center, this point which you have marked as center, R again as radius, draw a curve until it intersect with both the verticals on either side of an axis line. Okay, both the verticals on either side of an axis line. Fine. Again, wherever you got an intersection, try to draw a horizontal until the extreme end vertical. Fine. Then what you try to do, from here, wherever it got intersected, from here, draw an inclination of 30 degrees. 30. Align your drafter to 30 degrees inclination. Place it to this point. Draw a line of 30 degrees. Later, with your free hand, you can draw a curve, something like this. Okay. Now, I got the required profile or required shape. What I try to do is, I'll try to darken with HB pencil. Okay, this is 1 visible, 2 visible, 3, 4, 5, this profile. Okay, these are all visible to us, and also this line from here to this point is visible. This is about a front view. Now coming to the dimensions of the front view, here you could see this width is T is equal to D, that is equal to 20 mm. Fine, D is equal to 20 mm. Now again, this distance, this end point distance, here it is Q, which is equal to 40 mm, which is equal to 2D. Till here it is okay. Fine. Now what about the threading part? Because there is an internal circular hole of diameter D. How to draw the threading part? Here I need to draw a circle. The same circle I need to represent here in the top view. D is equal to 20 mm. Draw a circle of 20 diameter, means 10 is the radius. But don't draw the circle throughout 360 degrees. Okay, draw up to 75% only. I'll tell you how and why. Take this as center, 20 by 2, 10 as the radius. Draw circle up to 75%. Okay, and 2 mm less than that, means 10 minus 2, 8 mm. Less than that, draw a one more circle concentrically of 100%. Now this is the representation of internal threading. What is the representation of internal threading? The D diameter should be up to 75% only, and 2 mm less than that should be up to 100%. This is the representation of a threading. This outer one indicates D, which is equal to 20 dia. Alright, this is the top view, this is the front view. Other than this, you also need to draw a circle. As I said, now it will maintain a fillet followed by a circular object. You could see this circle again throughout the circumference that you need to draw, which will pass through all the edges tangentially. You could see here. Now this is a circle passing through all the edges tangentially. In actual practice or in actual manufacturing, same thing is applicable. This is how you will get the top view. This is about top view, front view of a hexagonal nut. Similarly, you also need to place the radius. This radius is R. What is R? Here it is shown. Okay, they may ask you to draw the side view also. Okay, they may ask you to draw side view. If that is required, draw the projections of front, draw the projections of top. Okay, consider any, I don't have much space here, so what I do is I'll try to take an extension till this point. Then again I'll try to take these extensions also, I'll try to, then from this particular point align your drafter to 45 degrees and 45 degrees inclination, draw this line. This is maintaining 45 degrees. Draw one more parallel 45 degrees line and one more. There are three intersections, draw 3 lines. Okay. Now from here draw verticals. Till here it is okay. Now again you got 2 boxes. This time both are reduced lengths only. Whenever you got reduced lengths, you need to maintain an angle of 30 degrees with respect to the horizontal. Same thing we will try to do here. Align your drafter to 30 degrees with respect to this horizontal and draw 30 degrees length. 30. HB pencil, try to darken the required lines. 1, 2, 3, 4, 5, 6, 7. Okay. These are the required side views. Okay. Fine. You need to maintain angle here. Angle of 30 degrees. Here also 30 degrees. That is more important. In few cases they may go with 45 degrees inclination also. In this case 45 degrees inclination also, but no problem if you go with 30 degrees. Okay. Front view, top view, side view. This is the representation of all the 3 views. Like I'll make a mark: front view, top view and side view. Okay. This is about a nut. If it is a hexagonal bolt, for example, if it is a hexagonal bolt, what happens? The same thing will be there. There will be a, make it small this time, there will be a hexagon followed by a shaft. Okay, something like this. You will have a shaft. Okay. Now this distance is more important. It is going to be this time t. It is not t is equal to d. It is equal to 0. Okay, 0.75 d in case of bolt. Fine. Now d value will be given. What is the given value in both the cases? Value of d is given 0.75 d. That is the thickness. U will remain same. Alright, d value will be, and r, value of r. What is value of r? Again same value need to be considered. Okay. What about the length of the shank? Now this length, maybe you can consider it as 4d, and from bottom till the length of 2d consider threading. Consider it as threading. Now overall shank length is 4d and there is a threading up to 2d from the bottom, and having a head dimensions of w is equal to 2d, t is equal to 0.75d, d value is already given in the question. Okay, I'll try to place here, try to understand and to try to place the hexagonal bolt in this place. Okay, when I view from the side, what I could see is again a hexagon. I'll try to take a extension line of the same vertical again. Okay, again I'll try to place a hexagon. This time I'll try to rotate the hexagon. I'll try to place it here because I'm trying to place the hexagon linearly this time, not vertically, horizontal I'm trying to place. So here again what we need to know, how to place a hexagon. So initially we have considered for a nut here, this as the width. Now rotate your width, consider this as your width. So I'll make a mark of W and centrally I'll try to place an axis line. Then again I'll try to draw a circle with 2H pencil. Then again as it is, take these as the radius, this as the center, maybe take this as A, this as B. A as center, make a mark above and below. B as center, D as radius, make a mark above and below. With your HB pencil, try to darken the edges, join them all. 1, 2, 3, 4, 5 and 6. This is about a hexagon. Now other than this, what you need to know, draw the shank level also. Now what I try to do is, I'll try to take all the projections like the way we did for to draw the front view of nut. I'll take them all, 1, 2, take a projectile line up to some infinite distance and draw a vertical parallel to the axis, vertical axis, and consider distance 0.75d. From here make a mark of 0.75d, close the box. Okay, extend this projectile lines, extend. Now this diameter d is equal to 20 we are considering, that is what given in the question. For example, this is d, extend this line till 4d distance, extend this line till 4d distance. Okay, close it. Okay, from here again make a mark of 2d to place your threading. How to place the threading? From here up to 2d, draw a double line with an offset of 1 mm. Draw a double line with an offset of 1 mm. Okay, take a shape of this kind, consider this shape. Now this is 0.75d. You need to place this value with the help of a dimension line. After this, again r is equal to 1.5d. Make a mark from here, make a mark of r in a vice versa way. Again draw a curve, draw the horizontal extension, extend the line, make it 30 again. Similar to the way we did for nut, 1 and 2, 30, 30. Okay. After this, directly go draw with a HB pencil all the required visibilities. This is visible, smooth curve is also visible, darken the lines. Okay. Again draw this extension, again show this profile. Okay. This is about a nut which is having a thickness of 0.75d. Then again an overall length of from here to this point, an overall length of 4d, out of which 2d is threading. Okay, this is how we'll draw a hexagon nut and bolt. Okay, if this is my position, if this is the position of the observer, then you could see a circle also, circle of diameter d. In that case, what you need to draw circle also, circle followed by one more circle up to 75%. Okay, initially in case of nut we have drawn 75% external circle. Here we need to draw a 75% internal circle to show representation of external threading. Okay, to draw external thread, what we need to do, 75% internal circle, external circle. In this case, to draw threading internal, 75% external, 100% internal. Okay, there should be a gap of 2 m only. There should be a gap of 2 m. That's it, nothing else. Okay, now if this is the case, I'll try to draw one more sketch which is very much easier compared to these two, which is a square nut. Which is a square nut. For example, considers hexagonal. The square nut may be something like this. This is your square nut which is having a circular hole. Okay, then again circle passing through tangentially all the points. Fine. If this is the position, how the representations are. If this is the position, how the representations are. Consider this as first position, this as your second position. I'll try to draw the representations bit faster this time because everything is very simple. D value will be given to you. Only difference is you need to remember one thing. D value will be given in this case. Fine. What is W? In case of hexagonal nut, W is equal to 2D. Whereas in case of square nut, W is equal to 1.5 plus 3m. You need to remember this. 1.5D plus 3m. Okay. Whereas R is equal to 2D. A small change. Fine. That is the only change you find. Now, if my position is at 1, what I need to do? If 1 is my position, I'll try to draw vertical. Okay. Followed by, I'll go with the top view. From the top, I could see simple square. Whatever the dimensions given in the question, a simple square. Followed by, there should be an internal hole. What for internal hole? This is the representation. I'll go with D 75. Then again with a reduction of 2m, one more circle. Okay. Again, I'll go with a projector line from here to this point. Fine. Where I'll start my front view. I'll close somewhere here. Now, what is T? In this case, T is equal to D again. That is the similarity. From here to here, I'll make a mark of D. I'll just close the box. Now, what is R? R is equal to 2D. Calculate 2D. If D is equal to 20, R is going to be 40. For example, if it is 40, from the intersection, make a mark of 40 somewhere here. In a reverse way, with the help of compass, taking radius 40, from here, draw a curve until it touch with the next vertical. This is done. Now this is your radius R, which is equal to 2D. Now take a HB pencil, darken the required visible part or a required part. This is about a front view and top view of a square nut when the position is here. If the position changes, if the person is standing exactly to this vertex point or a edge line, then the two edges are reduced lengths. If these two edges are reduced lengths, then you face problem with this curve. How to overcome that particular problem, we'll see now. The only thing is, again there will be a vertical, okay, but the position will change this time. When I'm standing here, the orientation of your square will change. these two corners will fall on a same single vertical, okay, and these two will fall on a same single horizontal. So from here to here, maybe I'll consider one horizontal, then again I'll draw this box 90 90. Okay, few students face difficulty to draw this box also. You need to consider W. Take W is equal to 1.5D plus 3m. Make a mark of that W. Make a mark of that W. Okay. Then consider D is equal to whatever the value given. Make a mark above and below. You'll get this box. Once this is done, take projector lines. Okay. Start somewhere away. I'll try to match up with this horizontal. Close this. Close. T is equal to D. Close the box. Okay. This time I got two reducer boxes. 2 reducer boxes. So R can't be placed here. If it is a true shape, R can be placed, which is R is equal to 2D. In case of reducer length, it is not possible. So in such case, what we need to do is, if the position is something like this also, we need to consider the true shape, initial shape, where the value of D is already given to us, which is equal to this distance. So again, you need to redraw this piece somewhere beside front view. That is more important. As you are already having this view, you can take an extension, but I'll make you understand. Now here what I try to do is, I'll take a projector line. I'll consider D is equal to 20 mm, whatever given in the question. I'll make a mark of D. I'll close the box. Then I'll draw a center line for this. I'll consider R, which is equal to 2D. From here make a mark of R. Again in a reverse way, draw a curve. The way we did for square nut first position. This is second position. Okay. Now wherever this curve got intersected with the next vertical, take that projector line onto the front view. Now you got these two boxes. Ultimate aim is to get these two boxes to place that 30 degrees inclination. That is what we did from the hexagonal nut bolts till this particular point. So now we got two reducer length boxes. Align your drafter to 30 degrees inclination. Go to the intersection and draw those 30 degrees lines. We have drawn this true shape to get these two boxes, or to get this width. That is the only intention. Okay. Now take a HB pencil, darken the required 1, 2, 3. Okay. And this is not required actually. So if you want, you can make it dark also, not a problem. Fine. Now this is about the orientations. This is the first position of hexagon square nut, second position of square nut. In a similar fashion, you have a square bolt also. The arrangement is so very simple in case of square bolt. Again, the dimensions will not change. Thickness will be same for square bolt, and width will also be same for square bolt. Okay, threading length will also be same for square bolt. So I'm not going to draw in detail. This is about hexagonal nut bolt, square nut bolt. Fine. This is about what? Hexagonal nut. This is what? Hexagonal bolt. Fine. First position nut, first position, square nut, second position. Okay. This is a 3D representation to make you understand better. Okay. Ultimately, you need to draw the views in your drawing sheet, whether you deal with your internal examination or external examination. And beside this, you need to write all the formulas, standard formulas. Don't forget to write the formulas aside, followed by, and along with that, you need to place the specifications also. This is equal to W. No need to place the value now. T is equal to D. This is R. This is D. That is enough. Place all of them aside of that particular drawing. This is about hexagonal nut bolt, square nut bolt, which you come across every day in your life. You can see physically also. Thank you so much. If you have any doubts, you can comment. Thank you.